Welcome to Ham Radio Perspectives. I'm Tom, W89TDD.
I'm Quinn, K8QS. Thanks again for viewing our videos, gang. We want to help you the best we can, and we've got a great topic for you and a spectacular guest, actually a guy who's now legendary in ham RF issues, and that's Bob, AK6R. And Bob is with Palomar Engineers. In fact, he bought the company some years back and has really transformed it into a spectacular company, doing all kinds of things. I'm going to provide a link down below so that you can go to the company. It's called Palomar Engineers, but it can be a little confusing when you first do an internet search because there are other engineering electrical things with Palomar. Palomar Engineers, this is Bob, it's a doggone pleasure to have you on here. Thanks for doing this.
Well, I'm really welcome to be here and just to give our message out to hams and let them enjoy radio even more than they do now.
Yeah, especially in an age where there's so much RF interference out there, RFI we'll call it. So let me start out with two things that happened, and then we'll get into this because this is a fairly specialized presentation we're doing on one kind of product that most of you have never heard about. And so about 2 months ago, I watched a presentation on the Palomar Engineers site. Bob has put quite a few of his PowerPoint presentations there, and it was talking about common mode noise filters, which is a term that Bob and his company came up with. It's not the common mode you think of when you're transmitting, okay, and you've got common mode issues, the RF is coming back down and you're getting bit by your microphone and all that stuff. But it's a different kind of thing that Bob's going to tell us about. And then I saw on his site that he had these things for sale. Now, this is a big one for higher power. I don't have higher power right now, but just in case I wanted to get one. And it's called a common mode noise filter, as we just talked about. And there's a little test that Bob's going to tell you about that you can do to see if you've got that. I had it about once I put this in, it dropped my noise level down about an S unit and a half. So let's say that's maybe 10 dB, something like that, just kabam, like that. I couldn't believe it from this stuff. And that's not transmit again, that's receive noise coming in. And then I noticed on a video that I did about how to call CQ on a band that's dead. It's been a very popular video. First, how do you check to make sure the band is really open and then call CQ? And I did this and a guy commented on it. And he said, I can't believe your noise level is so low. You know, you live out in the middle of nowhere. I said, no, I'm in a condo community here in the city, but I work hard on getting the noise down. And this is one of the things that's done it. It's absolutely miraculous. And one last thing, Bob, I shouldn't take this long, but I have this on my desk so that on the top of it is this right here. Yep. Made in America, because Tom and I have talked so much about how much ham equipment is really made in America anymore. So we're going to talk about common mode noise filters. And then I'm going to show you the site in a little bit when Bob has done the website with the different versions of them and levels and so on. So Bob, it's all yours, buddy. Take it away.
Okay, thanks for having me here. And it's always great to be live and to talk to people about noise in general. We are in a digital age now, and noise is all over the place, from switching power supplies to LED lights to washing machines. Anything made by a particular manufacturer, I'm not going to tell you who, but it starts with an L, is very, very noisy, particularly their refrigerators and also the washer dryers. They'll put 10 dB of noise on your AC lines. And so one of the things with noise in general is it's always better to fix the source, get rid of the source, than it is to protect the victim. All right. In other words, don't put filters on your radio. It's better to find the source of that and stop the source. And that way you don't have the problem on any of the bands, including the one that you're operating on. So, and we're going to show you how to do that in general in a second. And we have solution kits where you, the victim solution kit, or vice versa, if you have a solar panel or a mosquito light or whatever it happens to be, we have filters that you can put on that. and prevent the AC power lines from becoming the transmitting antenna for you, which happens an awful lot. So let's get started. There's a real simple test for noise, and one of those tests is if you turn on your radio, pick the band that you want to be on, and then the first thing you want to do is to unplug your coax, completely unplug it, and see if you still have noise. And if you still have noise, guess what? The noise is coming in somewhere else other than the coax. All right, it's a simple concept, and that's what you have to track down first before you attack the antenna problem, which is a whole other thing that we're going to be talking about too. And a lot of the times, you may have a switching power supply going into your radio. You may have a USB cable that's noisy coming from a computer, which has got a switching power supply, and the braid of the cable comes in and makes the receiver noisy at the same time. Likewise, there may be other things plugged into the back of it, including multiple antennas on some of the newer radios, and they can cause that issue too. So you can unplug one thing at a time, see if that's causing it, and if it is, you know at least that's a source. And if it's a source that a ferrite can fix, you can use one of the specific ferrites. And if you don't know anything about them, you can go to our website. There's lots of free downloads that educate you on what's a good ferrite, what's a bad ferrite, which is one that can solve your problem now. Or just buy the kit for an ICOM 7300, for example, put it on the back, and you don't have to worry about it anymore. So a couple of ways to do that. But in general, you have to fix the non-coax noise sources first before you attack the coax. Now, let's show you how to attack the coax problem. The first thing you need to do, of course, is to unplug the coax and solve the first problem. The second thing you need to do is to take your coax, take your PL259, and roll back the outside of it, all right? So that when you put it into the coax slot, you're only putting in the center conductor, all right? And this represents the signal that's coming directly from the antenna down the inside of the braid and the center of the conductor. Oh, did I mention? I always ask a question at the presentations I do at the Hamfest. And the first question I usually ask, by the way, is how many conductors does coax have? All right. And I
put my picture up there so I can tell you it's 3.
Yes, it's 3. But I tell you, half the people, they raise their hand and they say 2. When I say, how many think it's 2? And half the people raise their hand. And the other half usually say 3. They're educated, okay? And so if you think there's only 2, you got to do a little study, or make sure you look at that question on the extra exam that says, what is skin effect? And basically the outside metal braid on a piece of coax has 2 conductors, an inner and an outer, because that's where RF travels at its frequency on each side. So it actually creates a third conductor. So anyway, getting back to where we were, if you put the center conductor into the back of the radio, and then go measure your noise level, and do it on every band too, by the way. Some of the bands, like the low end bands, 160, 80, 60, and 40, for example, may have a different noise level than the 20 through 6 meter bands, for example. And the reason is, to get to the bottom line, is that your AC power lines in your house are similar in length to an antenna for those bands. And as a result, anything that's plugged into that AC power line, wall warts, digital supplies, you name it, refrigerators, for example, they use the AC lines around your house as antennas. And your antenna that you plug in with your ham radio stuff on it does its job. It receives signals. And if those signals happen to be coming on your AC power lines, they come in stronger than normal DX signals, for example, and they'll override it, and all you'll hear is noise across the band, or maybe on certain frequencies. So anyway, look at each band and measure the noise level, whether it be S1, S2, S3, write it down. And now we're going to do an extra test after we got that done. Go back to your original band, and what you want to do now is screw in the outside of the coax connector and make that measurement again. And for example, on 80 meters, during the day, 80 is a disaster. It's very noisy, but it also is a good indicator of noise sources like solar cells and solar arrays and those types of things. So what you do is when you screw in the outside of it, see if the noise level increases. It goes from S2 to S4, for example. All right. And now what that represents is that's the noise that's picked up by the outside of the coax braid, not the inside, the outside of the coax braid. And that is called common mode noise. So about 13 years ago, I guess it was, when we bought this company, my wife and I bought it. I got to keep her in there when she sees this video. And we made it a women-owned business, by the way. We bought the company, and we created the term coax noise filter. Nobody had ever done that before, so we created one. And it was a little 500-watt one in a little black box, which I'll show you in a little while here. And we installed that at the radio, of course, in line with the coax. And lo and behold, the noise level dropped 2 or 3 S units. All right. The common mode noise level dropped 2 or 3 S units. Let me repeat that. Only the common mode noise drops. The noise that's coming down the center represents the signal and the noise that the antenna actually hears, and it will not affect that at all. All right. So if you have common mode noise, your S meter jumps up when you screw in the back of the cable, then this will help solve that or suppress it. If you don't have any change, check the other bands to make sure that all the other bands are the same situation. They don't have any noise either. And it may be that you have noise on some bands, but not others. And as a result, the noise filter, which covers all bands from 1 to 3 to 6, will certainly help out. You guys have a comment?
Yeah, real quickly on this, Bob. I want to make sure everybody understands this. So to test for this kind of noise, disconnect the PL259 completely, assuming you're using a PL259, and then put in just the center connector so that the outer part of the PL259 does not touch the so-called ground on the outside of the SO239 on the rig. You have to keep those separate. All right. And then when you push in or screw in the outside, you're going to notice a difference in noise. And that's what I noticed. And that's why I bought this. So now when I make that test on all of the bands that I use, I don't have that noise anymore. Mm-hmm. It's gone. What created it out there, who knows? But that simple test will tell you whether or not buying one of these common mode line noise filters will make a difference. So I'm sorry to interrupt you, Bob. I just want to make sure everybody gets that.
No, that's fine. That's a good way to to illustrate that. The other thing I want to mention is if you have multiple antennas going through an antenna switch, unplug them from the antenna switch first, and then test them individually. Don't run them through the common coax that goes to all the antenna switches. And we'll tell you why later, but just take my word for it. You have to do those individually without the other antennas connected to it. Okay, let's see here. We talked a little bit about the noise on the low-end bands. It's typical that you would have noise there, not as much as you have on the high-end bands, which is typical. The reason that you have noise, all right, on the coax is the reason that you use chokes in general. Okay, if you're transmitting and you're pushing a signal up to the antenna, all right, at the top of the antenna, when it's going to be connected to the center conductor, it goes to that side of the dipole, for example, and the inner part is supposed to go to the other side of the dipole. Well, guess what? There's a fork in the road, all right? And the fork is that there's another conductor connected to the inner at the end of the coax. So part of it will go on the antenna, but part of it's going to come back down if there's not a stop sign, all right? That stop sign is called a feed line choke, all right? And it can be represented by a balun with a choke in it. It can be represented by a choke that you put in line, for example. But it's got to be something. It's got to have enough resistance or enough common mode rejection dBs, and typically that's about 20 dB. You have to have enough of that so that it stops the current from even having any hope of going down, all right? So what you want to do is make sure you put a big impedance there, and as a result, all of the RF that's transmitted will stay on top of the antenna, all right? Otherwise, guess what? The coax, if you don't do that, or you don't have a choke, the coax becomes part of the antenna. Now, it may be only 10% of the antenna, but it becomes part of the antenna. And as a result, if you when you change the length of the coax, you change the impedance at the end of the coax where you're hooking it to the radio, and it will change, all right? And by gosh, there are some, for example, off-center fed dipoles out there who do not put a choke in there in purpose. They want you to use the coax because that's the only way the antenna will tune. And it's got to be at least 50 feet long, okay?
Yeah, and I've got to tell you on that one, I think the company that is the major manufacturer of OCFs has exactly that problem.
Yep.
And
they do.
And in fact, the way they make the casing, like this casing here,
Yes.
they put the SO239 on the inside.
Yes.
And you can't even get your PL259 completely tight on the outside.
Yep.
And this is the major company selling these off-center feds, and they have no choke in there. So if you want to add a choke, you can't get it on there properly. It's amazing to me, Bob.
It's amazing. That company, by the way, has been sold 3 times from the original guy that developed it. And I have a whole presentation on off-center fed antennas. We're one of the largest off-center fed antenna manufacturers there is, too. And our offsets are different. We use 80-20 versus 66-33. And as a result, we pick up a lot more bands. And our baluns are so wide, broadband, they all go to at least 6 meters.
Right. And that 15 meters is the real killer with a lot of OCS.
Yeah, you can't get it on a 66-33 offset. You got to go 80-20. And there's some other magic things that we do, too, with resonance compensators to make sure each band is low. But anyway, that's another subject. And there's a whole presentation on that and a very good educational documents on the website. We have a whole set of documents, by the way, called Helpful Technical Guides. They're all free to download. You don't have to do anything, and except you have to put your email address in, create an account. But other than that, you can download as many as you want, as many times as you want, and it's a real educational experience. And there's one called Off-Center Fed Dipole Confidence: how to design, how to select, and how to use those. And it's been a very, it's on the left-hand corner there. It says helpful technical guides in the product categories. And all those are free, and they cover every subject, including some non-ham subjects, all right? And you'll like I say, you can download those. And some of my presentations are also in there. So feel free to do that and learn a little bit about all types of different ferrites, antennas, and also how to apply them. And is it something that you can use in your shack? So
it's just terrific what you've done here from an educational standpoint, Bob. I'm so glad you and your wife bought the company and really took it this direction. We'll do another video with you later about antennas, because I think you are now one of the largest wire antenna makers in the U.S.
That's correct. Interestingly enough, we never thought we would be an antenna company.
Yeah.
But over half of our sales now are antennas.
Amazing.
And principally end-fed long wires. We do not do end-fed halfways for a whole bunch of reasons. And we also do off-center fed dipoles. And
so
a lot of those. So anyway.
Yeah, I know you do a great antenna. So let's just go down the site here a little bit to look at what we're talking about. So you've got
that one's specifically for TVs.
Right.
If you have or 75 ohm ones, TV RG6, I guess it is. You need one of those if you have interference. The other ones here are they're all 50 ohms, and they come with various types of connectors. You can get them with N's or BNCs or SO239s or whatever. And
so if we click on one here, we get down here. Now we see a coax common mode, and then you can get.
And by the way, each one of our products has got a graph that goes with it. That includes our antennas too. We give you expected SWR graphs. Nobody else does that. So in this case here, it's common mode rejection ratio, and you can see with that green line that that's the amount of rejection of the current that's coming on the bottom of the antenna. All right, and I can't read it this unless you click on it. Then it becomes bigger. Now, if you look at the left-hand side, you can see what the scale is, and the scale is roughly 20 to 30 dB, and it's across the whole band. I mean, that goes from 0 to 60 megahertz, and you can see that. What does that mean? That many? If it's 30 dB, that's 5 S units of suppression, and if you only have 2, well, certainly it'll get rid of the 2. All right, so you want to make sure that if you look at anybody else's common mode noise filter, or choke for that matter, and they don't publish that graph, it's like buying a resistor without resistor codes. All right. Well, you don't know what you're getting, but it says it's a resistor. All right. Well, it says it's a choke. All right. But you have no idea what the frequency range is, or how much it chokes, so to speak. And whereas we publish all that stuff and let you know exactly where to place it, and whether it's going to work in your situation or not. In this case here, you see a graph that has the chokes at the antenna feed points, and then it's also got the common mode noise filters before the antenna switch. I should make a note that you always want to make sure you put your common mode noise filters on any point before it gets into your shack. So a lot of people use lightning suppressors, and they have a box outside with lightning suppressors with a common bus bar, right? And so you want to put your chokes, when we get if you have multiple ones coming in, you want to put your chokes out there, or your common mode noise filters out there, rather than putting it on the antenna, because by then they're all combined anyway. It's not going to do any good. You see?
Yeah. So, yeah, I think I told you before we started the video here, excuse me if I'm repeating myself, but Tom and I did a video on testing a vertical antenna against off-center fed I have up here that I made. And a guy made a comment on the video. He said, well, that's not a legitimate test because you're using an antenna switch that's got the outer part of the coax connected, the same one, to both antennas. He's absolutely right. And so a lot of these tests that are done, people don't think about that. Anything else you want to tell us about this particular product?
Yeah, there's a couple things, and let me just spend a few seconds on the whole antenna switch issue. And we had talked about that. I have a little sample here. This is a typical, let me get it positioned here correctly if I can. This is a typical antenna switch. It happens to have, we're going in and out of focus, of course. It happens to have 3 connectors to it, all right? And a lot of people use these, and then there's a common choke coming out, a common piece of coax coming out the other side. And so what you need to do is put the common mode noise filter, these are 500-watt versions, into the switch, either with a small jumper, or in this case, we used a double male barrel connector, and they just hooked in there. I use a lot of flex radios, as you can tell in the background, and they all have eight of these on each one. And on each one, because I have 8 antennas, for example. And so every one of those has got the larger version, which is the kilowatt version. They're just like that. We make them in tubular. We also make them like Quinn has in the box format, because some people like to mount them on the wall, and they can use it that way. A lot of other people want to let them hang from the antenna switch, and so we do it both ways because there's not room to put all the boxes, for example. So the antenna switch problem, like we said before, is not known by a lot of people because they don't either have noise, they live with the noise, or they don't use that antenna anymore, something like that. But here's the principle. If you're selecting an antenna 1 and all the braids are connected together, there's no filters in them, and the noise, and let's say antenna 1's a quiet antenna by itself, all right? Now you put it into an antenna switch, and antenna 3 is next to your neighbor's solar, all right? However, his braid is picking up the noise, and the braids are not switched in the antenna switch. Only the centers are. So guess what? They're all in parallel. So anytime you select antenna 1, you have 4 antennas that you're selecting. You have 3 braids, and then you have 1 center. And that's the noise that comes down the common coax connector into your radio. And putting a noise filter there does some good, but you still got all the noise from all three of them together. So it's better to take a noise filter on every one and isolate all those braids before you put it into the one that you're actually going to use. And I'll mention one more thing, and that is, it's just the opposite problem. If you have all these radios, like I have 5 radios, go into an antenna switch, and then that goes to one of those linear amplifiers you see behind me. It's the exact same issue, except it's on, you're selecting radios this time. So you may have a radio, it may be turned off or whatever, but it may have a power supply that's still on internally, like my FT101MP, for example. It's always on unless you turn off the back switch. And nobody does that because you got to go behind the radio to do it. But it's always on. And so those types of things cause all the radios to generate noise. And that noise, unless you put the small 500 watters on the back of every radio, which I have, it solves that problem, and you don't have noise on radio 1 affecting radio 2, even though it's turned off, okay? And you do the same test, by the way. Put the center conductor in, screw in the outside, see if it's an issue. And if it isn't, then you don't have that problem. But it's always a good idea to put it on there anyway, all right? On the linear amplifier itself, of course, you put a linear amplifier RFI kit, because guess what? All the RF does not go out the output antenna, right? Some of it bleeds through and comes back through the input on the braids, all right? Some of it may come back on the push-to-talk relay switch. There are all kinds of ways that RF gets out, and it all doesn't come out the tonal that it's supposed to, all right? So you need ferrite filters and those types of things to solve that issue too, all right? So let's see, what are things that I want to talk about? We talked a little bit about the coax, the receive. Okay, so some people have the understanding that if I put a choke at the top of the antenna, my noise will go away, and that's not the case. Feed line chokes in general work on transmit, and they only work at the top of the antenna. The chokes that you put, or the coax noise filters that you put at the radio end of the antenna, are used for noise suppression. Because, and I don't think I mentioned this point, the outside of the coax acts as a great receive antenna. And a lot of people will take their coax and they'll run it through the attic, okay, or they'll run it real close to other noise producing devices in their house. All right, I found a new one the other day, which was mosquito lights. Right, the gals who work in the production shop use this mosquito light because they get a lot of mosquitoes. Well, when that thing was on, it was 20 dB across the 80-meter band. And I run a net on Tuesday nights it's called the vintage sideband net, where you have to check in with the radio before 1981, right? And as a result, they don't have noise filters like the new ones do for the digital stuff. And boy, you could hear that thing all over the place. But anyway, that's another source. So that's one thing you want to look out for. And
Hey, Bob.
Yep.
I've got following along here. I've got a couple of questions for you.
Sure,
Is
you
that a
have.
moment?
I'm about done with the stuff that I wanted to tell people
Okay.
about. So
I'm about to get started here. But so we've all agreed, and most hams know that most of the man-made noise is coming from appliances or LED lights or
Yep.
bad transformers or so. What about suppression of atmospheric noise?
Well, let me ask you: are you a flat earther or are you
No.
There's a different answer, right? No.
Atmospheric noise. I'm in a rural area. I have very little common mode. I've done your test with the coax.
Okay.
And most of my noise here is caused by atmospherics, lightning, static. Does your filter clean up that?
If that signal is being caught down by the center of the coax, the answer is no. There's not much you can do about those, right?
Okay.
And
So
because there's nothing that'll filter that. It's broadband noise across the whole spectrum. I mean, it goes up to the gigahertz.
okay. So then in a noisy environment, does your filter cause any attenuation?
No, it does. Well, you can look at the attenuation numbers on it, but typically it's less than a quarter dB. Typically it's 0.1 dB. So they're very, very little attenuation. That's never been an issue for anybody that we used them.
So then there wouldn't be any appreciable insertion loss.
No, not at all. In fact, they'll pass DC. So if you're doing DC biasing to antenna switches, for example, it goes right through them. It works perfect.
Okay. So is the noise shunted to an earth ground, or how is it eliminated?
Well, typically you'll have a station ground, all right.
Right.
But if you think about it, most of the common mode noise is less than 5% of the total on a transmit basis, all right. And on a receive basis, I don't know how much you know about ferrites, but in a quick sense, a ferrite is a frequency dependent resistor. That's all it is. And they have much more resistance to current at high frequencies than they do at low frequencies. For example, a simple snap-on ferrite may have a resistance, a signal one with one turn through it, may have a resistance of 200 ohms, right? But on 80 meters, that same one has got a resistance of 40 ohms. 30 or 40 ohms. And so it's 10 times the difference practically. All right. Mm-hmm. And so on 10 meters, you may need 4 or 5 in a row to get the 20 dB, but on 80 meters, you need 20 of them with one turn through them. That's why sleeve balance are a fallacy at low frequencies. You always got to use something with multiple turns through it. Mm-hmm. And as a result, they work a lot better. But if you use ferrites, they will, in a lot of cases, reduce that noise at DC frequencies, switching power frequencies, those types of things.
That's great. You have another question, Tom, or not?
No, that wraps it up for my usage.
Okay, so gang, just to summarize here, Bob from Palomar Engineers will put a link down to his company. I did not ask Bob to send me a free one of these so we could review it and make some dough on it. I saw that these things were working, so I ordered one myself based on the test that Bob explained, and it nailed that particular common mode issue for me. And my guess is that many of you have the same issues. And if you go to the website, as we were showing here, and we'll link down below, you can see there are different units at different power levels. The basic one for, what's the lowest? Is it 100 watts, I think?
100 watts is the lowest, yeah.
Yeah, and it's very inexpensive for the 100-watt one. And so give it a try. Give it the test. And I'm so glad that you bought the company, Bob, but I'm also glad that along the way, you got into this whole thing, because this is a problem that almost every ham has if they're in an urban area, especially, and yet almost nobody knows about it except for what you're doing. And
we're trying to educate a lot of people,
right?
And it's worked too.
So it's the common mode noise filter. Check it out. And thanks so much for watching, Bob. We're going to have you back again. We've got a couple of other topics that we want to do with you. And so stand by, as they say. This is Ham Radio. Yeah, this is Ham Radio Perspectives. I'm Quinn, K8QS.
I'm WN9TVD.
Yes, so, and we've been here with Bob, AK6R. Thanks, everybody, for watching 7-3.
You're welcome.